This is Math 3, 5.3 notes. That's Math 3, Unit 5, Lesson 3. The title is Modified Box and Whisker Plots. You will need a calculator, and again, if you are able to print, please print because there's a lot of writing again on these notes. Okay, make sure to fill that information in. 5-number summary box and whisker plot. The standard deviation is a great way to measure the distribution of the data when the data is normally distributed. If the data is skewed left or right, then the 5-number summary describes the data better. And these are the 1, 2, 3, 4, 5-number summary. Min, which stands for the smallest value of the data set, the minimum. Q1, it's the first quartile. We'll talk about how to find it. MED stands for median. Q3 is the third quartile. And max stands for the largest value in your set of data. Okay, first quartile. You find it, it says it is the median of the first half of the data set. Do not include the median to be part of any half of the data. It'll explain as we work it out. The Q3, the third quartile, is also the median, but of the second half. This one's of the first half, this one's of the second half of the data set. Again, do not include the median to be part of any half of the data. Okay, create a box and whisker plot for the data set. State whether the data is skewed left, skewed right, or normally distributed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If there's an even amount of numbers, you're not going to have one middle number, so you'll find the average of the two middles, and I'll talk about that when we do it. All right, first thing you're going to do is put these numbers in order. So I'm just going to start to write them. 3, 4, 5, 3, 4, 5, 6, 7, 8. Is there a 9? 9. 10, 11, and 12. Okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, because there's an even amount, you'll look. When I go through to count the middle, the median, there's two middle numbers. So since there's two middle numbers, it's not gonna, I have to average them. I add them and cut them in half. So in midway between 7 and 8 is 7.5. And you can check that. 7 plus 8 divided by 2 is indeed 7.5. So the middle is 7.5. And I don't include that in either half, but I do include the 8 to the right and the 7 to the left. Since I didn't use 7 or 8 as my median, I used its average. The 8 goes to the right and the 7 goes to the left. So now I have 1, 2, 3, 4, 5, which means this one has a middle number. It is 8. That is my Q3. Put a little note there. That's my third quartile, and I find the middle here. Remember, the 7 counts. Okay, so I'm going to the left of that purple line, and I count to the middle, and that middle is 5. And this is my Q2. I'm sorry, that was Q1. That is my Q1. My Q2 is the median. We just call it the median. Q1, first quartile, is the median of the first half of the data set. Here's my first half. The median is 5. That's my Q1. I keep saying Q1, good grief, but yet I keep writing Q2. Q1. My Q3 is the median of the second half. Here's my second half. I counted my way to the middle. The median is 10. So there's my middle. There's my Q1. There's my Q3. Min and max. My minimum is 3. My maximum is 12. 1, 2, 3, 4, 5 pieces of data. The 5-number summary. My min, my max, my middle of the first half, and my middle of the second half. All right. Now, the way we plot this is we count across. Now, I can't start at 1 because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I need to go up to 12. And I can't start at 1 either because I need to, well, actually, I could start at 1 because it would go up to 3, but it wouldn't go all the way to 12. So We can try 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would work. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You do not have to start at 0. You do not have to start at, in this case, you could have started at 3 because 3 is my first number. Your first number has to be making sure you get your smallest number in there, which I can, and your 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so again, you just want to make sure it fits in there nicely. All right, 3 is my smallest number. I'm going to put a marking there, and 12 is my largest number. I'm going to put a marking there. Okay, 7.5 is midway, so I'm going to put a marking there. 5 and 10. And here's how I make the box and whisker. I'm going to erase my start and end so it doesn't confuse you yet, and just put my 3 inner, my median and my quartiles. So my quartile 1, my median, and my quartile 3. And then you make your box. And your box starts at your first dot and goes to your third dot, from Q1 to Q3. And you draw a line down the median. And that's the way your box and whiskers always, we haven't done the whiskers yet, but this is the way the box part is going to work. Okay, so a line at your Q1, a line at your median, a line at your Q3, and then you make a box, and then you extend these two out to your start and end. Your start was 3, so I'm going to make my whisker go out to the 3, and then my end was 12, so I'm going to make it go out to the 12. And there's my box and whisker for this graph, for the set of numbers, and it's not skewed right or left. We'd say it's normally distributed. It's normally distributed. Okay, moving on. How to modify the graph. A box and whisker plot could become modified when you indicate if outliers exist in the data set. We'll talk about outliers. Okay, an outlier, we're going to do that right now, an outlier is a value that doesn't follow the pattern of all the other data values. Outliers could have a drastic effect on the mean of the standard deviation. So, in order to determine whether or not you have an outlier, you must calculate 2 boundaries. We'll talk about what those boundaries are. There's a lot in this lesson, so you want to make sure you're paying attention. We're going to calculate 2 boundaries. Any data value larger than the upper boundary and the lower boundary is considered an outlier. So those are the 2 boundaries we're going to find. I said here we're going to find 2 boundaries. One's the upper, one's the lower. So any number that's outside, it's smaller than the lower bound or bigger than the upper bound, is considered an outlier. If a data value is equal to either boundary, it is not an outlier. We'll talk about it as we go. If an outlier exists, and the whiskers can be drawn to either Q1 or Q3 to then the highest value not beyond the boundaries. Again, it's kind of confusing now. We'll talk about it as we go. Use a dot or an X to indicate the location or locations of the outliers. Sometimes you have no outliers, sometimes you have only 1, and sometimes you can have more than 1. So 0, no outliers, 1, 2, or 3, just depending on the problem. In order to find the upper and lower bounds, you first need to find the inner quartile range. Inner quartile range. And I'm going to call that IQR. Inner quartile range, IQR. Okay, and here's what it is. Here's the formula. How to find the upper and lower bounds. The upper the lower bound equals your Q1 minus 1.5 times your IQR. Your upper bound equals your Q3 plus 1.5 times IQR. So in both of them, you're going to find 1.5 times your inner quartile range. And over here, you're going to subtract it from your Q1, and over here, you're going to add it to your Q3. Okay, now create a box and whisker plot based upon the data below. Now this here is supposed to be printed on the next page, so when I upload your document, I'll have it correctly. On mine, when I printed it, this was supposed to be on the next page. So put yours in order. Yours should already be on the next page. Put them in order, and I'm going to do that now. I'm just going to put them in order on the next page. And you can go ahead and hit pause while you put them in order, and then hit play and see if we have the same thing. All right, I'm just checking. Okay, so check yours. I have 1, 10, 12, 15, 15, 15, 16, 16, 17, 18, 19, 20, 21, 25, and 42. Okay, so I think I counted 15 numbers, which means I'm going to have a middle. So we're going to count our way to the middle number, and it is 16. That is your median. Okay, and then use the data above to create the 5-number system, the 5-number summary. Okay, so the middle is 5, the median. And now I'm going to find my Q1, or we can find the min and max. The lowest number is 1, the largest number is 42. And then we're going to take the middle of the left and right half. Since I did have a median, he doesn't go on either side. You have that half, and the 16 does not go on either side when you're counting. 1, 2, 3, 4, 5, 6, 7. Because it's an odd amount, I do have a middle number, and that middle number is 15. That's my Q1. My Q1 is 15. And then I'm going to count over here my way to the middle, and I get 20, and that is my Q3. And so my Q3 is 20. Okay, I found those. Determine the inner quartile range, the lower boundary, upper boundary, to determine and identify any outliers. Okay, so the first thing we find is the inner quartile range. Remember, the inner quartile range is, guess what? I didn't give it to you, so let me give that to you now. You do need that formula, so let's write it down. I'm going to put it here. IQR will always, range means to the largest number minus your smallest number. So inner quartile range means your largest quartile minus your smallest quartile. Did you get that? Range means your largest number in a data set minus the smallest number in the data set. So inner quartile range means your largest quartile Q3 minus your smaller quartile Q1. Okay, so let's go ahead and find that now. IQR, inner quartile range, equals Q3, which is 20, minus Q1, which is 15. You can do this, Q3 minus Q1 to remind you what you're doing, and 20 minus 15 is 5, so that goes here. Your lower bound formula is, you're going to multiply the inner quartile range times 1.5 and subtract it from your Q1. So you're going to take Q1 minus 1.5 times your inner quartile range. Again, I'm just rewriting the previous formula. So Q1 is 15 minus 1.5 times inner quartile range is 5. So you will need a calculator. 1.5 times 5 and you get 7.5. So you have 15 minus 7.5. 15 minus 7.5 is indeed 7.5. So your lower bound is 7.5. Okay, upper bound equals, I'm just going to rewrite the formula from the previous page, Q3 plus 1.5 times your inner quartile range. Now we're adding. Q3 is 20. 1.5 times the inner quartile was 5. We've already done 1.5 times 5 and it was already 7.5, but now we're adding it. 20 plus 7.5 is 27.5. Okay, and lower bound is 7.5, so an outlier is going to be any number smaller than 7.5. These are all bigger, 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 bigger. That's the only one that is smaller, so 1. And sometimes it's possible to have no outliers or only one outlier. Okay, let's check if we have any on the other side. Anything bigger than 27.5. These are all smaller, 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 smaller until I get to 42. That is much bigger. So 1 and 42 are my outliers. They're not an ordered pair. There are just two outliers that I have. One is 1 and the other is 42. We will finish the rest of these notes in class. So you're not turning this in until we finish this in class. That is it for now.